everybody. I hope you're getting along with all the new terms, and we're still in intervals. And in the last lesson we learned that there are two types of intervals. There are the perfect intervals, which have only one size in tone, and we have the imperfect intervals, which have two sizes. For example, if we take the E and the F, the name of the interval is a second, but its size is a semitone, from here to here. On the other hand, the G and the F and the G are also an interval of a second, because we count FG, just as we have counted EF. But if we look at the keyboard, because we have this black key between the two, between the F and the G, the size of this second is a whole tone. So we have two types of seconds, and actually the first second we will from now on call a minor second, and the second type of second we'll call a major second. So if we want to give the correct name for each interval, from now on we will have to use the name of the interval, say a fourth, a second, an eighth, which is an octave, but we will have to add also some kind of suffix. Say if it's a perfect interval, we would say a perfect fifth, a perfect eighth, but if it's an imperfect interval, we'll have to add this suffix, say major second, major third, minor third, etc. So as I said, to know this exactly, we have to use a table, which I want to construct now with you step by step on the board. But I'm enclosing here to this video a link to this table written properly, printed. Now I'm taking, only as an example, the note F, and I'm adding to this F each time a slightly higher second note, second tone, to be exact, a semitone higher every time. And through that we're going to pass over all the practical intervals that we need to use. So I'll begin with F and itself, and that's, as we know, in the first method of measuring the distance between two notes, we know that this distance is already called 1. It's called a first. And the first is a perfect interval. Its size is always 0 tones. So here I write the name above, and below I write the size in tones. So in tones this is 0, because the distance between a note and itself is nil, is no distance. So it's a 0. But if I take the F and the G flat, you can see here the F and the G flat, that's a semitone. Now the name of this interval is of course a second, because I count F and G. You remember, we always begin with this a method of counting the names of the tones. In order to get to the name of the interval, we count the names of the tones. So this is an F and this is a G, and F and G are consequent, so this is a second. And it's actually a minor second. It's a minor second. Why? Because if I take the F and the normal G, from here to here, you see it's a whole tone with the black, which is the G flat key between them. So this is called a minor second, and this we will call a major second, and its size in tones is 1. Let's go on. What's the next note, which is a semitone higher than the G? From here, it's this key. What key is this? This is an A flat. So from F to A flat, that's 1.5 tones, and the name now changes because we have now 3 names, F, G, and A. So that's a third. Now this is a minor third because we have a bigger third, which is from F to normal A. From F to a normal A, that's a major third. Let's go on. From F, semitone higher than A is the B flat. We come to B flat, and that's, if we count the names of the notes, it's F, G, A, and B, and it doesn't matter whether it's flat or sharp or normal, that's a fourth. Now the fourth, as I said, is a perfect interval, so we just write here perfect. Okay? Now, excuse me, this is two tones. The major third is two tones, and the perfect fourth is 2.5 tones. Now I come to three tones, and that's called the tritone, and I'm going to leave the space free for now, and I'm going to skip to 3.5 tones, and that's the distance between the F and the C. From F to C, let's see how many tones are there. As you see, from here it's a tone, another tone, another tone, three tones, and a semitone, so it's 3.5 tones, and that's a perfect fifth. Okay, let's go on to the sixth now. There is no major fifth, so it has to be that the next interval has another name, and indeed the next interval is the sixth, which is the distance between the F and the D flat. From here to here, that's a sixth. Now that's called a minor sixth, which has the size of 4 tones. Why is that? Because we have a sixth which is larger than that, which is from F to normal D, and that's a major sixth, which has the size of 4.5 tones. As you can see, my keyboard has miraculously expanded, so now I can measure the distance between the F and the E flat, which is the next size, which has 5 tones, whose size is 5 tones, and that's the minor seventh. And a semitone higher, if we take the E flat, that's from F to normal E, so that would be the major seventh, which has the size of 5.5 tones. And finally, we come to the F, and the F which is right above it, and that's of course an octave, which is an eighth, and it's a perfect interval, it's a perfect eighth, an octave, which has, as we have already said, 6 tones. Now, what about the tritone? What about this interval which has 3 tones? It's actually the distance, now I will write it between the F and the normal B, or it could also be written as the distance, the interval between F and a C flat, which is actually the same note. As we have already learned, notes have usually at least 2 names, 2 different names. So this is actually 2 ways to spell the interval of tritone. Now the tritone has always been a problematic interval, historically also. There was a period, actually in the Middle Ages, in which this interval was considered as demonic, as the interval of the devil. There was even a proverb, si contra fa, diabolus in musica. F against B is the devil in music, and it was forbidden to write it, especially harmonically, because mathematically it's queer. And I think what's even queerer is that it really sounds odd. Listen to a tritone. It really sounds like the devil, doesn't it? But what happened? You hear? The tritone suddenly became very friendly, even essential. And we have to have the tritone in our modern harmony. The tritone is essential, but it's essential because tension is sometimes obligatory. In order that the music sound interesting and powerful, we have to use sometimes unstable intervals. So it is really unstable, and also in the calculation of intervals, it is problematic because what name can I give this interval? If I write it like this, its name actually would be a fourth, because from F to B is always a fourth. And if I write it as an F and a C flat, it will be a fifth. But which fifth would it be? Could it be a minor fifth? It can be minor fifth because fifths are perfect intervals and they have only one size. And really, usually, the octave always has one size, but most of the fifths are indeed in the size of 3.5 tones. Or we could call it a major fourth, because the normal fourth is 2.5 tones. But again, the fourth is a perfect interval, and most fourths in the octave are 2.5 tones. So we can't call it a major fourth nor a minor fifth. So we call it a supernatural fourth. We call it an augmented fourth or a diminished fifth. And these titles really emphasize that something is unnatural here, because usually the intervals are either perfect or major or minor. But when I say augmented, it means that it's unnaturally oversized or diminished, unnaturally, that it has shrunk unnaturally to a smaller size than normal. So this is really an exception. That's a very strange interval, but that's actually the practical table. And in the next lesson, we will learn how to use it in order to construct and identify the exact size of each interval. I hope all this was clear, and I'll be more than happy to answer your questions. So bye for now.